Hello students, in today's lecture we are going to learn about concept of rotating magnetic field in three-phase induction motor. In last class I have covered introduction to induction motor, then applications, advantages, types of induction motor along with the construction features. Now next part of that three-phase induction motor is concept of rotating magnetic field. Now let me begin with that concept. As we all know that when we give electrical supply to any winding, a magnetic field get induced. For example, if DC supply is given to the winding, there is a magnetic flux phi or magnetic field get induced. But when you give a single phase AC supply to the winding, then alternating flux is going to set up, as we have seen in the single phase transformer. Now when you give balanced three phase AC supply to the balanced three phase stator winding, a magnetic field will get set up, but that magnetic field is rotating about its axis. Now in this class we are going to understand how that magnetic field is rotating in nature or about its axis. To understand this, we need to derive the derivation, or we need to prove that magnetic field is rotating. To do that, we need to consider 3 points importantly. So those 3 points are as follows. One is three-phase flux waveform we have to consider, assumed positive flux direction we need to consider, and three-phase flux equation along with the cases we need to consider, and we have to prove it. Let's begin. Here I have drawn three-phase flux waveform. Whenever three-phase AC is given to the three-phase winding of stator, it induces flux in it. So that flux is nothing but, of course, three-phase flux. Three individual flux will get induced in three different windings, and these three different windings will be placed in the stator slots, and it will be connected in such a way that there exists a fixed phase relationship between these three windings, exactly 120 degree between those three. Hence whatever flux induces, there also a fixed phase relationship exists, that is 120 degree between all the flux. Now that same thing I have shown in this diagram. Here flux phi r is started its journey from 0 degree, and it is reaching maximum value at 90 degree and reaching its first one half cycle at 180 degree, and next it is reaching to the negative value minus maximum value, then to the 360 degree. That means it completes one cycle duration here. In the similar way, phi y, which lags behind the phi r by 120 degree because winding is placed in that position. So hence it started its journey at 120 degree and reaching maximum value here, positive maximum. Here it is continues in the negative value. Similarly, if you consider phi b, flux induced because of the B phase, this is lagging this pi r by exactly 240 degree. Hence because of that, whatever fluxes are induced in the stator winding, there exists a fixed relationship of 120 degree. This concept we should know before understanding the RMF concept. Now next I have drawn the assumed positive flux direction, so that here we have seen this phasor diagram of three-phase AC supply. So this phi r I have drawn in this direction. It is I have considered this as a positive direction. If you want to draw the negative direction of this flux, then it will exactly opposite to this phi r. You can draw this side. Similar way, phi y, this is the positive direction, you can draw negative direction in this way, and phi b is you can draw in the this direction opposite to that positive value. So by drawing that, you can draw the negative direction also, positive as well as negative flux direction also we can draw. But here right now I have considered the positive flux direction, and there exists a 120 degree phase relationship. Now after seeing this, Now I have written here three-phase flux equation. This flux equation is nothing but here in first I have shown in terms of waveform. Now same thing I have written in terms of equation. As we all know that in three-phase AC generations we used to write the EMF equations in individual EMF equation in the every phase or each phase. For example, R phase induces some voltage, Y phase induces some voltages, and B phase induces some voltages. So that can be written ER, EY, EB, EM sin omega t, EM sin omega t minus 120 degree, EB is equal to EM sin omega t minus 240 degree, that we know. Similarly, when this EMF get induced, in the similar way, their flux also induced in the winding. When the flux is inducing in that winding, that equation can be written in this way: phi r, phi y, and phi b, and equation is given by this equation number 1, 2, 3, and this equation number 3 can be written minus 240 degree, or it can be written plus 120 degree also. Now with the help of this all the concepts, this three-phase flux waveform, positive flux direction, and this equation, now I can derive or I can prove that the magnetic field produced in the stator winding is rotating in the nature. That let's see now. That can be explained with the help of considering the cases. The first case I will consider that omega t is equal to 0. Now putting this omega t is equal to 0 in the above equations 1, 2 and 3, I will get phi r is equal to 0 degree, because sine 0 is 0. Next, sine minus 60 is nothing but 0.866, and this phi b you are going to get 0.86. The one is negative value and another one is positive value. Out of 3 flux, one flux becomes 0 and other 2 flux are existing. Now I want a resultant flux. How to get resultant flux? That resultant flux can be obtained with the help of phasor addition of this phi y and phi b. I can obtain a resultant flux, or it can be called a total flux. So now phi y is the negative value and phi b is positive value. So phi b I will draw in this same direction as in this way because it is positive, but phi y is a negative value, so I will draw it in this direction. So that is what here I have drawn. Phi b in this direction same positive value, but phi y is the negative value, hence instead of drawing here I have drawn in this way. Now phasor addition of this phi y and phi b, we are going to get phi t or phi r, that is nothing but total flux or resultant flux. I am interested in the resultant flux or total flux. Now I have drawn a perpendicular from B on this phi t. Then what happens? This OD becomes equal to dA, hence this pi t get divided by 2. Now considering this BOD triangle, so it is I will consider cos angle. So cos 30 degree is equal to adjacent divided by hypotenuse is nothing but OD divided by OB. Same thing I have written here, cos 30 degree is equal to adjacent by hypotenuse is nothing but OD by OB, and OD is nothing but pi t by 2 divided by OB is nothing but 0.8665 m. And after simplification, what I am going to get is pi t is equal to 1.5 times phi m. That what it means, the total flux or resultant flux in that is equal to 1.5 times of the maximum flux available. This is the magnitude of that magnetic field, and the direction of this total flux is in the upward direction. It is in the upward direction. This can be done with this calculation can be done with the help of different methods. You can use law of parallelogram or law of vectors, that is nothing but pi t is equal to square root of pi b square plus pi y square plus 2 pi b 2 pi y cos 60 degree. Then put the values of pi y, pi b and that cos 60 degree values, then definitely you are going to get the resultant flux. Otherwise you can use Pythagoras theorem also, and you can determine this total flux value. Now next we will move to the second case. Here omega t is equal to 60 degree I will consider. So phi r is equal to root 3 by 2 we are going to get. Why? Because phi sine 60, sine omega t is nothing but, sine 60 is nothing but 0.866 phi m I am going to get, and phi y is 60 minus 120 is minus 60, again it is minus 0.866 phi m, and pi b is equal to 60 minus 240, it is 180, so it becomes 0. So flux phi b becomes 0, and there are two flux are existing, and I want to determine the resultant flux or total flux, and that can be obtained with the help of addition of phasor, this flux phasors. Now when you add this, then I will get this total flux. Here I have drawn from B to D a bisector I have drawn on the phi t. So OD is equal to dA is equal to pi t by 2, and if you consider this angle, triangle cos 30 degree, then it is root 3 by 2, and adjacent is OD, or this is pi t by 2, and OB is minus 0.866 phi m. You can consider in that way, and it becomes minus 1.5 times phi m. That minus indicates that it is the negative value, it is the negative flux in the negative cycle. Otherwise you can consider in this way also. Instead of drawing this bisector from B to D, you can draw from C to D also, and consider this triangle O DCO or DOC triangle you can consider, and cos 30 degree is equal to, adjacent is remains same OD, but hypotenuse will get changed, it is becomes OC. That is what I have written OC. So that time you will get the positive value. So hence phi t value whatever you are getting 1.5 times pi m. So direction doesn't matter for me now here, that negative value or positive value, but the magnitude remains constant. It is 1.5 times the maximum flux. At the same time, the direction of that rotating magnetic field is now, it is moved from initial condition. Initial condition, it was in the upward condition in this position. Now from this position to, it is moving this position. So there is a movement is there for the rotating magnetic field. If you calculate similarly with different values, omega t is equal to 120 degree, 180 degree, 240 degree, 300 degree and 360 degree, then what you are going to get for 120 degree resultant flux will be in this direction, and for 180 degree exactly downward you are going to get. For 240 degree in this direction you are going to get the resultant flux, and for 300 degree you are going to get in this direction, and finally for 360 degree you are going to get again in the upward direction. That means for one complete revolution, as the time is changing, the flux direction is also changing, and this is what we call magnetic field is rotating in nature. It is not stationary or it is not alternating. It is rotating in nature. It is about rotating about its axis. It is rotating in the space. Hence, we are going to say that the magnetic field produced in the stator winding is in the rotating in nature. Hence, the name rotating magnetic field. And whatever this rotating magnet, this RMF is created, it is rotating at particular speed. And that speed is given by equation ns is equal to 120 f by p, where f is the supply frequency and p is the number of poles in the stator. Suppose number of poles p is equal to 4 and frequency is 50 hertz, then what you are going to get, ns is equal to 1500 rpm. What is indicates? It indicates that the rotating, the whatever magnetic field is rotating, it is rotating at 1500 rpm. That is what the meaning of 1500 rpm. In this way we can prove the magnetic field produced in the stator winding is rotating in nature. With the help of this explanation, I will conclude today's lecture. Thank you.